Welcome to Unit 7 on Similarity and Transformations. Now in the first half of the unit, we will be looking at enlargements and reductions of an object and then determine the scale factor. Or if we're given a scale factor, we have to draw the enlargement or reduction ourselves. We'll also look at similar polygons and similar triangles and their properties. Then in the second half, we will look at transformations such as rotations, reflections, and translations, and look for any line or rotational symmetry that may occur. So we'll start with Lesson 1 on scale diagrams. Now a scale diagram is a diagram that is an enlargement or a reduction of another diagram. And in enlargement, it means the diagram got bigger, and in a reduction, it means it got smaller. And this enlargement or reduction is the result of applying a scale factor to the original diagram. So let's look at scale factor. It is the ratio of corresponding lengths of two similar shapes. And the way we find scale factor is to take the length of a side in the scale diagram and divide that by the length of the corresponding side in the original diagram. Now if this value is greater than 1, then we have an enlargement, and if it's less than 1, we have a reduction. So let's look at this example. Here we have the original diagram, then here we have the scale. Now since the scale is smaller than the original, then that means we have a reduction. And when I find the scale factor, I also know it should be less than 1. So now to find the scale factor, I'll take the length in the scale diagram, 2.5, and divide that by the corresponding length in the original, 5. Now 2.5 divided by 5 is the same as 1/2, which is less than 1. Now we can write scale factor in a few other ways. We can write it as a decimal and say that is 0.5. We can take that decimal and change it to a percent by multiplying by 100. Or we can also write it as a ratio, 1 to 2, where the first number corresponds to the length in the scale, and the second number corresponds to the length in the original. Now let's look at another example. An example where scale factor is commonly used is in the blueprint of a house. So here it says the blueprints of a house have a scale of 1 to 200. So what this means is that if we take our ruler and measure 1 centimeter on the blueprint, then that corresponds to 200 centimeters of the actual house in real life. Scale factor is important in blueprints so you can get a bird's eye view of the house, and since everything is scaled down, you can make sure that everything fits before you go ahead and build it. Now, when finding scale factor, it's important to make sure that you have the same units. If not, you're going to have to change them. So here's some common conversions you may need to use. 1 meter is equal to 100 centimeters. 1 kilometer is equal to 1,000 meters. And 1 centimeter is equal to 10 millimeters. So an example where you might need to convert, this is the next example where we have a map. So down in the bottom corner of the map, you'll see the scale here. So on a map, you get out your ruler and you measure this distance. I measured it to be 5 centimeters. Now what this corresponds to, actual distance, is 8,000 kilometers. So since the measurement on the map is in centimeters, and that corresponds to kilometers in real life, when we find the scale factor, we're going to have to change the units. So let's look at that now. So here we have 5 centimeters corresponding to 8,000 kilometers. So to change my kilometers to centimeters, I'm going to first change it to meters. Since there's 1,000 meters in a kilometer, I multiply it by 1,000, and I get that 5 centimeters, 8 million meters. Then I take the meters and I change it to centimeters by multiplying that by 100. So now I get the same units. 5 centimeters corresponds to 800 million centimeters in real life. So to find the scale factor, I'll take the scale length, which was 5 centimeters, and divide that by the actual length, which was 800 million centimeters. And then I just reduced that to be 1 over 160 million. So maps on a diagram is another example where we have scale factors being used.